Okay, good morning. Okay. All right, let's look at chapter 4. That's where we are. We're moving to chapter 4. And in this chapter, we're going to review very quickly the Cartesian coordinate system. Okay? So that's when we combine two lines, the horizontal line and the vertical line, and they form a new graph. They form a new graph, which we call this Cartesian coordinate system, okay? And the horizontal line is called the what? What is it?
X-axis.
It's the x-axis. What's the vertical line called?
Y-axis.
The y-axis, okay? It's because I'm getting distracted, guys, okay? If I'm getting distracted, this is what I'm going to do. So the second time is this, okay? All right. So in this system, we have what we call quadrants. This first section is called the first quadrant. Here's the second, here's the third, and here's the fourth quadrant, right? This should all be reviewed. And in order to graph something, we give you something like an ordered pair. So something similar to even what we did that other day with that game where I had all the open boxes and and you were like B5, okay? So we're going to be graphing using two coordinates to get us to a place, okay? And that's going to be an ordered pair. So the ordered pairs you have are always, okay, they're always going to be the x coordinate will come first, and then the y coordinate, okay? So give me something here in this ordered pair that gets me in the first quadrant. Give me something that I can graph in the first quadrant. All right, Alexis.
1, -8.
Okay, let's try that. All right, 1 and -8. Let me see if that's good. So remember when we're doing the ordered pairs, I'm going to go first on the x and then on the y. So first on the x, she's asking me to go to 1, and here's 1. And now, Alexis, you're asking me to go -8, right? So here's -8. Is that in the first quadrant? Where do you need to go? Okay.
You would put the negative first if you want.
Wait. Well, hold on. I go here 1, and now where does the y need to go? Does the y need to be positive to go up, or does it need to be negative to go up? You want to be in this range, in the first quadrant.
Positive.
So I'm going to go positive. So give me any number through these, right? 5. Okay, so here's 1 and 5. That's what she's giving me. I'll graph it right there. 1 on the x and 5 on the y. And that is in the first quadrant. The first value being the x, or the horizontal movement, if I'm going positive or negative, and that's just like the regular number line, okay? All right, and the second one being the y, whether I go up or down. Connor? Yeah.
-3 and 7.
Okay, so I'm going to find something now in the second quadrant is what Connor's doing, and he's telling me -3 and comma 7. So this is the x value, the -3, and the y value is 7. Let's check it out. Okay, so I'm going to go -3 first. So negative goes to the left or to the right?
Left.
To the left. Here it is. There's my -3. And now I'm going to do the y movement. And the y movement tells me to go up or down. Am I going to go, when I go 7, am I going up or am I going down? I'm going up. So here's my 7. It's up, and there it is, right there. That's -3, 7. That's that point. Find me something that lands me in the third quadrant. Okay, Max.
-5 and -7.
Okay. -5 and -7. Let's check it out. So Max is telling me to go -5 on the x or y. Where does the -5 go? X or y? It's the x value. So here I am going -5. Here it is. And my y value is what? My y value is -7. He's telling me, do I go up or down? I go down. So I'm going down to -7. Is that in the third quadrant? Yes, it is. -5 and -7 is right here. Can you see that you're going to need to start using graph paper for homework? Okay, so you have to start using your graph paper tonight. All right, and let's find something in the fourth quadrant. Okay, Javi. 8 and -2. Okay, so we're going to do the fourth quadrant. 8, -2 is going to be the point. Let's check it out. The value 8 is going on the x. Do I go to the right or to the left to go 8? Ben, it's up there, okay? Just in my brain, it's up there. So am I going to the right or to the left? To the right. It's going over 8. And now where do I go for -2? Down 2, and here it is. Okay, so that's 8, -2 right there. So we're just remembering this, how to graph points, right? Okay, and now we're going to use this graphing stuff, the graphing of the points, to help us interpret some data. Ben, well, you're just looking back there. Stop looking at each other, okay, everybody? No, not right now, but before, okay? It's so distracting to me, and it causes us to lose time in class, okay? So don't turn around and be looking, like, look. I have my people that look all the time at each other and do stuff. Don't do it, okay? Okay, all right, thank you. So let's open up your books to page, it's 4.1. Let me get back there because we moved around a little bit. 203, okay. We didn't do one on the axis in the last class. Let's do that. What if I land something on the axis? Give me something that lands on the x-axis. Go. 0, -9.
Oh, no. No. Yeah.
Let's check it out. Let's check it out.
-9, 0.
Okay, so we want something that lands on the x-axis. That's what I'm asking first. So Gus is self-correcting, and that's awesome because that's what we all need to do in life. So we just need little adjustments, okay? So let's find something. So call that thing number 1 you just did. Let's do something landing on the x-axis. Land on the x-axis. And what was your ordered pair, Gus? -9 and 0. Okay, so let's check it out. So I'm going to go -9 on the x. So that takes me to the left, right? And here it is. And I'm going to, hi Brian. And I'm going to go up or down 0. Thank you. And there it is. And that landed on the x-axis. That's it. Okay, -9, 0. Find me something that lands on the y-axis. Just give me a y-axis bordered pair. So I'm just going to keep using different language to say the same things. Peter.
0 and 1.
Okay, so he's going over 0. Here it is, 0 and 1. If I go over 0, I'm on the y-axis. And now I'm up 1. And here I am. It is 0 and 1 is on the y-axis, so that's good. Okay, turn your page. Any questions just about plotting points, reviewing that? Yes. I need your, just come up with your pass thing. Okay. All right, let's look at a scatter plot now. Okay. We did something a couple chapters ago that gave us data in a format where we could read it, it consolidated it, so we could understand it in a certain format. There was something we've done where we've already organized data. What was a format that we used to organize data? Peter? Ooh, that is good. Yes, that organizes data. Yes, awesome. You're awesome.
I know.
Come up here because you're awesome. Tell me, I want something else though too. Something else that we use to organize data. Connor. That's great. You weren't even here, Bailey. That's, yeah. It's something, they're going to have to get it. Peter, come here. Peter, I'm giving you a dum-dum. Camilla. Sorry. Yeah. Graphs. Yes. Okay. Graphs show us, they interpret data for us, don't they? They do. Okay. That's good. I guess I'm looking really specific. I shouldn't be looking so specific. It was something very different that we did. Procedures. Matthew. Okay, that's another organization of data. Yes. Leanne.
The line for it?
Yeah. Vincent. This is great. Oh no, it's true, but there was something we did that was very different, and we added them and subtracted them.
Matrices.
Okay, I'll give you two. All right, I'm gonna give it to Matthew. All right, JJ. I got a bunch of dum-dums. Dum-dums and smarties. Okay, all right. So what we're gonna do is just find another way to interpret data. And what we're doing today is gonna be called, it's scatter plots. Let's check it out. Page 204, right at the top, okay? Many real-life situations can be described in terms of pairs of numbers. Sorry, I've gotta get something stuck on myself. Okay. In terms of numbers, medical charts record both the height and the weight of a patient. Weather reports might have things like temperatures and wind speeds. So one way to analyze the data and to notice trends, basically, is what we're going to be looking at, is to graph them in scatter plots. Guys, just a little self-control, okay? This is what I need. Look at example 2. Okay? So here you are, you're the student manager of your high school soccer team. When you're working and you've recorded the height and the weight of your 11 players. Okay, so Peter, I'm putting it up here. I gotta just teach, okay? So here we have our heights. Do you see how tall these guys are on the soccer team? 72 inches, 70 inches, 71, 70, 69, 70. And what about the weight? 190, 170, 180, 175, okay? So here they are. This is an older soccer team, yes, to weigh that much. So letter A. They want us to make a scatter plot of the data. Put the height on the horizontal axis and put the weight on the vertical axis. So look at that. So look at the first one. Let's go down and put your finger on that graph. Find me how much the person who's 66 inches tall, how much do they weigh? What is it, Connor? 150. And now I have some people that are 69 inches. What do they weigh?
150 and 160.
150 and 160. How about the 70 inches tall people?
50 and 150.
Okay, all those 4 people, they're weighing a lot of different stuff, aren't they? Okay? Do you notice on this scatter plot, so I'm just plotting data, here it comes, it's coming in the form of each person, each unique person, okay? And it's showing a trend. Do you see a trend yet on this scatter plot? What could you tell me? We've got to interpret this data. Come on, give me information. Okay, well okay. Use the scatter plot to estimate the weight of a player who is 69 inches tall and one who's 71 inches tall. Look at the 69-inch person. Okay? How much do they weigh? Give me the two weights. 150, 160. So now I'm looking at what can I estimate a person will be if they're 69 inches tall?
155 pounds,
Why?
because it's between 150 and 160.
It's just between those two, okay? It is. All right. Now they're asking us, how about the person who's 71 inches tall? How many data points are there for that one? Connor?
1,
There's one data point, so about how much do they weigh? 180. So for that, our guess is just going to be the 180, okay? If you have multiple sets of data, we found the average of those, okay? All right, let's look at letter C. In general, how does the weight change as the height changes? What happens?
the weight increases.
Yeah, the taller you're getting, the more you're weighing. That's what it's showing. That is the tendency, okay? And then letter D, what would you expect a player who's 74 inches tall to weigh? So go to 74. Is there anybody at 74? No. What are they going to weigh?
175.
Around 175? That's a little low. That would be low. Do you put your finger on 175? 74? 190 could be a guess. 195, okay, would be the top of the range. And 169 is a little low. It's out of the range. 183. So you have the idea that we're going to pick numbers in between these.
180.
This scatter plot is showing us kind of like a pattern that's almost a linear pattern, okay? My smiling 8th and 9th grader people, okay? All right, it's showing us basically a linear pattern, okay? Let's look at the next problem. All right, so here we are on this next problem, and we're gonna start going into winter sports. How many of you ski? Okay, how many of you do snowboarding? That's fun. Okay, how many of you ever snowmobiled? Oh, that's fun. Okay, all right. So we're going to take a scatter plot and map this data. So let's look at this year. In 1990, these were the numbers of, this was the number in millions of dollars spent on these different sports. So the people who did snowmobiling, you know, you guys are going to have to, wow, I'm just irritated today. There's like 322 million spent on the snowmobiles, right? How much more was spent on that ski equipment? A bunch more, almost twice as much, right? Okay, so 1990, there's 606 million spent on skiers and ski equipment, okay? Let's come down and look at this scatter plot now, this graph. Do you see that on the x-axis, they have the years being measured? Yes? Look at your x-axis. What is my first year? 0 is the first year. And what does 0 represent? No, oh, it doesn't represent something. What does 0 represent? 1990. Woohoo. Okay, and what does the 1 represent? 1991. Okay, all right. So there are the years, and look at the amounts of money. Do you see that little squiggly line down there? Mm-hmm. And do you remember what that means? What does it mean? Well, yeah, it won't be 0, but it's showing us what? It's showing us a little bit something more specific. Connor?
That it like jumps from 0 to
Yeah, we jumped from 0 to 200. Now, do you remember when we first talked about graphs that I'm losing my train of thought because I'm seeing people in class. Okay. But when we first talked about graphs, we talked about how information can be deceptive or more accurate depending on the way that it's given to you, right? So in this graph, you're not going to see all the stuff up to 200. And if you take like a magnifying glass and look at data more closely, you're going to find that the data is more dramatic, okay? But say we included all the numbers going from 0 to whatever the range is where the data stops. You'll see maybe a flatter line, a flatter curve, or whatever it is. It's going to be a more accurate look at that. Do you remember us doing that and seeing that? Some of the data was like a little bit deceptive, like, wow, that was such a big change, when it really wasn't. And if you put it in the correct scale, you could see that. We see that all the time. We're seeing it right now, like in the election and whatever. And even with COVID, we see it. Like, they have all these numbers of the cases of COVID, but yet a lot of them could be asymptomatic or whatever, or they might even be taking people who are dying of heart stuff, like a heart attack, but they have tested positive for COVID. And even though their heart has been bad and they've been on the brink of having heart attacks and dying, they get marked down as a COVID death. Well, is that really accurate? That's not really accurate. Like, you know, the COVID might, you know, push them over, right? I'm not making light of COVID, but I am saying that the data might not be represented accurately, okay?
So, like, if some guy got eaten by a shark and like his leg
And he had
washed up-
COVID?
his leg washed up on shore and it tested positive for COVID, they would say it was a COVID death?
I like that. Maybe. That would be so dramatic. That is a great, I want you to go into editorial columns and make a cartoon of that. That would be great. Okay? But it is true that some of this representation of it is being, you know, it's like the stuff we're talking about. Okay. Let's answer these. Yes, Gus?
That kind of happened to my grandfather, but
Well, he didn't even have COVID, but they still tried. He was tested and he was negative, and they still tried to mark it as a COVID death. And my dad got so mad at them. Oh my gosh! It was like honey.
Oh, I'm sure they did. I'm sorry, Gus. I'm sorry. Okay. Okay. All right. So now let's look at the pattern of the snowmobiles. So find me which color is the snowmobile color.
Blue.
It's blue. Okay. What's happening to the blue dots as we go along in time?
They increase.
From 1990 on to 97 there, it is really on the rise. It's increasing, okay? What's happening to the money that's spent on skiing? It's staying the same. It's pretty level, okay? So the skiers are all doing their thing, but the snowmobiling is increasing and getting more popular, okay? All right. And let's see what else. I think that's it for those questions, okay? So this gives us an idea of scatter plots. So I'd like you to take out your calculators now and turn to page 209. We're going to learn to put data in to a scatter plot. How many of you have your calculators?
I don't have a graph.
This kind of calculator won't work, right?
No, it won't. You have to have a TI 83 or 84. Who has their calculator today and who does not?
I lost mine.
Raise your hand if you've got your calculator.
Oh wait, no, I lost mine.
This whole half of the room. Wow, and this. Okay.
Does a TI-85 work?
Oh, wow. I haven't seen that in a long time. I used to see that at college when I worked at Nova.
Yeah, it's copyrighted 91.
Okay.
It's really old.
Yeah. Okay, that's a little bit different of a calculator. Your buttons might even be a little bit different. But anyway, we'll do our best. I don't know that calculator, in other words, okay? All right, so let's do what we can. And I want you you're going to follow along and just do this at home. So we're going to learn a little bit about this today and how to input.
I don't have a calculator.
You have to get one, Vincent.
Oh no, it's on my phone.
You did Vincent.
lost it.
Yeah, I know, but it's in my hat.
Well, find it. Pay your brothers and sisters to help you find it. Do something. Okay, the first thing we're gonna do, let's just look at this data. This is all Presidential Fitness Award data. Okay, stay with me. Okay, we've got age and years from 10 to 17. And they're gonna be running the mile run for the Presidential Fitness Award. So look at the first 10-year-old. What's his time? Yep, so almost 8 minutes, right? An 8-minute mile. Okay? The 11-year-old, 7.53, right? Okay? The 12-year-old, yeah? Do you see this? Now, what's going on with the data as we keep going toward the 17-year-old? What's happening? Yes. So in this case, you see the data. Vincent, this is a new seat for you. Chill. Okay, this is not your behavior up here. And your mom gets to see this video right now. Okay, I'm gonna text her and say, look at the video. All right, so we're seeing the pattern that the time is decreasing as the ages are going up. So what I'd like us to do, so we're gonna learn a lot of these features of the calculator today. So the first thing we're gonna do is put in our tables to the calculator so that this calculator will graph the information for us. So what I'd like you to do is go to your stat feature. So here's your button. So TI-83 and TI-84, this is your button right here, okay? That's the stat button. So click on that and you get some different options, okay? The option we want is to edit, and it's number 1. So how do I move on this calculator? Show me how to move your cursor on the calculator. What do you press? You press the arrows, right? So if I press the arrows, I'm gonna go up and down. How do I choose what I want? What are you gonna choose with? You're gonna press the enter key. So let's press number 1, the edit feature, okay? And enter that. And now you can see I have data already put in there. But you should have line 1, line 2, line 3. So this is your data that you're putting in. And line 1, what we're gonna do, they're asking us to put in the ages. So as you go in line 1, do any of you have information already in your calculator for these tables right here? Or is it blank totally? Do you have stuff on there?
I had a 1.
Okay, well you can just write over top of your 1, okay? So go ahead and just put your data in. So your cursor, I'd like your cursor to be under this first line of data, and we're gonna enter 10 right there. So just put 10, and I can enter 10 over top of my 10. I've already entered these. 11 is the next one. Do you notice that when you press enter, where is the cursor moving? It's going downward, okay? So go ahead and enter all your ages up to, I believe it was age 17, and there it was, okay? Any questions about that? So just enter your ages. Once you've entered those ages, yes, Gus, what's your question?
Where are you getting this information?
From the table that we just read, page 209. Okay? And so page 209, we have the ages at the top, on the top line of the table. The second line is the time. Okay, Vincent and Connor, I'm gonna just, it's up there, okay? Let's stop talking. All right, so for the second line, let's put in the time. The time for the 10-year-old is 7:95, okay? The time for the 11-year-old is 7.53 minutes, right? So just a little bit over 7.5 minutes, right there. Can you enter all those times? The time for the 12-year-old is 7.18 minutes. The 13-year-old, 6.83. Okay, so you can go down with your calculator and keep adding. I've added that data already. And how is it going? Are you doing fine? Is this the same button for you, TI-85?
Like, I do the stat, and then edit, and it's like X list, Y list.
Okay, good. Yeah, put your X list in as the 10, 11, 12, 13, the ages, and the Y list is going to be the time.
After name.
I'm not sure. Can I see what you have? Oh, boy. Oh, Lord have mercy. I mean, you can, why don't you press that button and see? I don't know that calculator at all. It's going to be totally different.
So put it in for name.
I don't know.
Okay.
I can't. I can't discern that like immediately. Okay. Okay, now let's go to number 2. And you're going to pick your window. And for the window, tell me what a window does, first of all. Just, what's a window do? What's it do? You see through it. You see. A window lets you see something, yes? If I have a big window, am I going to see more of that?
Yeah.
Possibly. If you have a really nice view, you might want a big window. If you're living in New York City, you might want a smaller window. I have no idea. But anyway, the window lets you see. So the window in math tells us what we're going to see. So I'd like you to press on the window feature. And here it is right here. It's this top second button. Do you see it right here? The top second button says window. Right there. So we're going to click on that and watch what happens. So we get window. And then it says X minimum, X max, has a scale, and then a Y min and Y max. What is an X minimum? What does that mean? It's the furthest to the left it goes. So let's look at the coordinate system. The X minimum would be the smallest value of X that you want to show. What would the X maximum be? The largest. What if I'm in millions of dollars? Then you want to have the maximum be millions of dollars. You don't want it to stop at 9 or 10 or whatever. You've got to have it go into the millions. For this time, what we're going to do is they're giving us this trend. They're telling us what to do. And they are saying, we would like your X values to be between 0 and 20. 0 and 20. The X values are standing for the ages, because can we have a negative age? Are we going into negative ages in some other weird dimension of life? No. Perhaps we could say, well, before we were conceived or whatever, we could say, oh, well, God thought of me. For all eternity, I was thought of. But we're not going into negative ages, okay? All right? So the X minimum, here's your minimum. The X minimum has to be 0. And they've asked us to put the X maximum at 20. Okay? So the top age would be 20. The top age on our graph goes to what number? What's the top age, everybody? Thank you. Okay, now what about that Y min? The Y minimum is talking about the times that it took these people to race this race. Yes? Okay, so let's go down to the Y minimum. By the way, so I could change it. I've already input this as 0. I'll do it again. You can press 0 on top of something. Press your arrow and it will go down. I've got my maximum already at 20. And I'm going to press down past the scale for a second. My Y minimum is the time it takes me to run the race. So the time it takes me to run the race, I'm saying, is going to be 0. Anybody run that race close to 0 minutes? But I'm going to start at 0 minutes, and I'm going to put my Y max at 10 minutes. So that's the longest that somebody's going to run that race. Yeah. So yeah. Okay. All right. And then we have, okay, so now go back to the scale. And look what they said with the scale. Okay, they'd like it to be 5, the scale, for the X values. Can you plug in a 5 there? So I already have a 5 plugged in for my scale here. Okay? And my Y values, they asked us on that paper there, page 209, to put in a scale of 2, and there it is, okay? This is going to give us a look into the window, what you want to see, okay? So now we're going to go use the stat plot button. Okay, so how do I get to stat plot? Look at this. Do you see? I'm going to This is your stat plot button right here. It's above the y equals button. And mine is in yellow. How do you get to yours? What color is yours? Blue? If it's blue, do you see a blue button on your calculator? So mine is yellow. So what do I do to get up to that function? Yeah, you press that button first. So I'm going to press the second button, and I'm going to press the stat plot, and it's going to take me to this feature that says stat plot. My stat plot is on. What does yours say? Stat plot off. Now this is going to drive us crazy in a little bit once we're doing the linear equations, but we're going to turn this on for today. So I would like you, mine is on already. I'm going to enter that. Press enter on line 1. Okay, so I'm going to go back here, and here we are for 1. Here we're going to plot this. Okay, plot 1 on. Okay, and I'm just going to click enter. Mine's on. Do you see there's two, you can toggle between the on and the off button by using the left and right arrows. I want it to be on, so click on and click enter. Okay. This is the type of graph that's going to be shown. You can press this first one here will be fine. We're going to do a scatter plot. It's going to plot the individual points that the ages and the time that they ran. That's what it's going to plot, okay? All right. Let's go back. I'd like you to click on second stack plot again. So if you have the blue button, go back to the stat plot. And I want us on this feature here. Do you see that we did list 1 here? We're on number 1. Okay. I'm just going to go to graph for a second and show you this. But if I graph that, that's what that first list looks like. And the first list represents their ages, but mine looks like it's going down. Hold on one second. This is really weird. Oh, no, mine is combining both of those two things. Yeah, it should be going down. Okay. So it's combining those two graphs. Okay, so I'm sorry. What I'd like you to do next, after we've done that stat plot feature, look at number 4. And click on the graph button. Can you click on that graph button? And you should see something like I'm seeing. Okay, so click graph. And it's going to introduce those 2 data points, you know, the age and the time that they ran, and it's going to put them into like Battleship, like B5, and give you a coordinate or an ordered pair. What is the trend? What is happening as the age increases? What is happening to the time that they ran? Look at the graph. What's happening? It's decreasing. The line is going downward. Yep. Okay. It's definitely going down. Okay. You don't need to use your calculator for your homework tonight. You don't need to do that, but we're going to start using it and seeing how it works. Okay? Can you help me, Ben? Kira, you're done. Can you help me, please? Let's get the paper towels out. So what is your homework for tonight? 4.1. How many of you did that extra bonus assignment that I gave you to help you with your grades? The cumulative review. Okay, I need that. Here, staple it over here, Ryan, and turn that in, please. Is there anybody that did not go to the testing center yesterday, or whatever we call it, our computer room? Oh my goodness, Ryan.
Where's the...
Right over here, okay. You've got to finish those. It has to be turned in, all the quiz